All right, so this ball is dropped from rest, and it falls from a height of 30 meters. The mass of the ball is 0.5 kilograms. The ball hits the ground and rebounds upward to a height of 20 meters. And they don't tell us this, but at that new height, what's the velocity? 0. So the ball comes down like this, faster, faster, faster. Bam! It hits the ground. Then it rebounds up, and it goes up, 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 up. The problem doesn't tell us this, but what do we know about this point right here? The velocity is 0. At the new maximum height, the velocity is 0. All right, so the question is, and then also the time of contact between the ball and the ground is 2 milliseconds, which is 0.002 seconds. The question is, what is the average force that the ground exerts on the ball? And let's just change. The reason they use average force, I mean, if you were to plot this like as a graph, force versus time of contact, when the ball first touches the ground, it's like, the force is 0. Like when the ball first makes contact, the force is very small. And then what happens as the ball smushes into the ground? I mean, we're slowing this down big time, like into thousandths of a second or hundredths of a thousandth of a second. It would look like this. It would go woo, like this, and this whole thing right here would be 0.002 seconds, right? So it's, what's the average force? So let's just replace average with net force. The net force that the ground exerts on the ball. So what's the equation for net force? F net equals what? Mass times acceleration. Do we have the mass of the ball? Yeah. All we need to find out the net force that the ground exerts on the ball, all we need is the acceleration of the ball while it's in contact with the ground. So when the ball hits the ground right here, when the ball smashes into the ground during this 0.002 second period, which way is the net force going to be? Is the net force on the ball going to be down, or will the net force on the ball be up? Which way will the net force be? Up. The net force on the ball will be up. And by the way, net force and acceleration, the net force and the acceleration are always in the what? Same direction or different direction? Same direction. The acceleration is always in the same direction as the net force. So here's what we got to do. To answer this question, we have to find the acceleration of the ball while it's in contact with the ground. Okay, so I got like 2 minutes or 2.5 minutes, so I'm going to do this quickly. So here's how you do it. To find the acceleration, let me revert this. To find the acceleration of the ball while it's in contact with the ground, we got to do a couple things. First thing we got to find, what's the velocity of the ball right before it hits? Like the moment before the ball hits the ground, what's the velocity? Well, if you do the calculation correctly, and I'll show you how to do it, it comes out as 24 negative, Remember, you got to pay attention to sign convention. Down is negative, up is positive. So this velocity right before it hits is negative 24.249 meter per second. Now, how did I get that velocity? I'm just going to show you. The way I got that velocity, Vf squared equals V initial squared plus 2ax. What's V initial up here? 0. So you're solving for V final. Square root of 2ax. What's your A? Negative 9.8. What's your x? Negative 30. Why is the 30 negative? It's going down. Okay, so and then remember, square roots are always plus or minus, so we have to choose the minus, right? Why is it minus? It's going down. All right, now we got to find the velocity of the ball right as it leaves the ground. So the ball hits the ground and then it leaves the ground. What's the velocity of the ball as it leaves the ground? Well, if you do the calculation correctly, you'll get positive 19.799 meter per second. How did I get that? With the exact same equation. Vf squared equals V initial squared plus 2ax. What's V final up here? 0. So now you can solve for V initial as it leaves the ground. You know, V initial is going to be square root negative 2ax, right? A is negative 9.8, x is 20. Okay, so now we have the velocity right before the ball hits, we have the velocity right after it hits, and we have the time. So now what can we find? The acceleration. How do you get the acceleration? You go Vf equals V initial plus AT. So A is going to be Vf minus V initial over T. So now you got to be careful here. So Vf is positive, right? After collision, hold on. This is 19.799 minus a negative 24.249, like that. Divide by 0.002, and then you get an acceleration of 22,000. Okay? Now, we can solve it. What's the net force going to be? F net equals ma. Here's your A. What's the m? 0.5. So you get a net force of 11,000.